Hello, I am Swati Verma, Assistant Professor, Chhattisgarh Swami Vivekanand Technical University, CSVTU Bhilai. I welcome you all to the course on Industrial Automation and Drives. Today, we will start with our 37th lecture on this course on the title SCADA Programming Part 1. In the previous lectures, I have covered the introduction to SCADA architecture and block diagram and also how to interface the SCADA system with the PLC. In these two lectures, I have covered about the introduction of SCADA, how the SCADA works, what are the main architecture of SCADA and what are the communication protocols of SCADA. And then we have also discussed how to interface the SCADA system with the PLC, the benefits of interfacing it and also the challenges we can face while interfacing the SCADA with the PLC. At the last, we have also studied how to interface the Allen Bradley PLC with the InTouch SCADA system. So now let's begin with our lecture. In this lecture, we will study about the SCADA programming. So for that, we will use the Wonderware InTouch SCADA software. Okay. After installing the software, a new window will appear and will ask you to enter the desired name for your project. As you can see in the figure, a window properties window will appear. Okay. In that, it will ask you to enter the name which you want for your project and also to add the additional comments if you want to add it about your project. Okay. It also gives you freedom to set the window color. Here you can see it is a gray color. You can add the your choice of color of the window. Set your choice of color. Okay. Also, it gives you freedom to choose the window type and to select the frame type and to also select the dimensions X and Y and also the width and the length height of your window. After selecting the window properties, okay, you can proceed for the simulation process. So let's take an example to get the better understanding of this SCADA programming or about the software. So in this new window, I have entered the name as an example 1 and the comment I have fed it Industrial Automation and Drive. Okay. Then when I will click OK, after clicking on the OK, a new window will appear which is called as a development window or the development environment. Okay. Now how we can select the components of the industrial process here in this SCADA software. So you can see a wizard icon on your development window, okay, in the toolbox. When you will click on this icon, the wizard section will appear. What is this wizard section? This consists all the type of the symbols which you will need to simulate your industrial process. Okay, got it? What this wizard selection includes, as you can see in the figure, it includes the ActiveX controls, the alarm displays, the button types, the clocks, frames, lights, meters, panels, runtime tools, the sliders, the smart symbol, SPC charts, the SPC limits wizard, switches, symbol factory, the test displays, trends, value displays, window controls. So all these sort of symbols are there. You have to choose which symbol you want for automation process, for display of your component. Okay. After selecting this, you have to click on the OK. Okay. For our example, I have selected a switch. You can see here there are many types of switch options are there. Okay. So here I have selected the first one called as the fixer switch. Okay. This switch, when you select it, this switch will then appear in your development window. Okay. After selecting it, you have to click on OK and it will get added in your development window as you can see in the in your figure. Okay. Then for the output indication, for the output side, I have selected the lights. Here there are many lights and different types of light options. I have chosen the circular light for my project. Okay. This switch and then light will appear in our development window. Okay. Now the next step is to interface or to connect this input switch to our output indicator or the output light. So you have to think, you have to keep this in mind that in SCADA, instead of physical wiring, we have to connect or interface our devices using the tags. Okay. So, to provide the tag name, you have to click on that input. Okay. Here when you will click on the switch, a window will appear with the tag name. Okay. So, for this I have chosen the SW or switch, short form of switch, as the tag name. After clicking this, a tag name dictionary will open. This tag name dictionary will provide, through this you can provide get the details of your input or the switch. Here the tag name is SW, here the initial value is chosen as off. Okay. Similarly, we can do for the other inputs you have selected. Okay. After, you can see in the tag name software show, the very important step is to select the type of tag. You can see here at the side of tag name there is a type. Okay. So, be careful while selecting the type of tag. Okay. Just clicking on the type, a tag name dictionary window will appear with all the type of tag options. So, these are, I will read out, these are the memory discrete, input output discrete, indirect discrete, memory integer, input output integer, memory real, input output real, indirect analog, memory message, input output message, indirect message, group variable, host trend, and then your tag ID. Okay. There are 14 type of tag options. Okay. As you can see in the type of tag, there are mainly discrete, either integer, either real, or the message type, and then they are separated by either by the memory or the input output. So, let us understand what are these tag types one by one. So, discrete means these tag types only have two states, means either it is on or off, 0 or 1, true, false, high, low, means where there are only two levels or two states, for example like switch. Okay. So, the switch comes under the discrete. Okay. Next is the integer, where we have a range like a slider, like a temperature measurement scale. So, here that we will use the integer type. Okay. Next is for the real, for the fractional values like 12.252, 11.13 or the 100 point something, we have to choose the real type. Next is the message type, when there is a alphanumeric value, for example where in which the character plus values are there or the numeric values are there, for example message 123 or alpha 123, here we use the message type. Okay. Now, in our software we have used in the memory discrete, okay, because we are doing the program in the software, and when we are performing our operation or the practical operation, in that time we can use the input outputs. Okay. When you are programming in software, you have to choose the memory type or memory discrete, but when you are performing the operation or the real operation, there you have to choose the input output discrete. So, in our program we have chosen the tag type, the memory discrete type, as you have seen in the figure. So, after completing this tagging process for the switch, we will do the we'll select the details of the light. Okay. When you will click on this light, the light wizard will open, as you can see in the figure. Here it comes the expression. Okay. So, here we want to connect our input switch to the output indicator. So, in this we will use the expression same for our tag name, switch tag name. So, here I have entered the SW, which is the tag name of my input switch. Okay. So, what does it mean? This same tag name expression will allow us to observe the operation of the switch in the form of light indicator. Means when we will operate the switch, it is linked to our light indicator, and or we can see the changes in our light output light indicator. Got it? Here we will also get the options to fill color. Okay. When it is off, which color you want, and when it is on or true, which color you want. So, here we have selected when it is off it will be red color, and when it is on with the green color. So, you can choose according to your choice, and it will also give us freedom to choose the blinking effect. So enable blink. So where it, which application we use? For example, if you want to alert somewhere of there is a fault condition, you want to alert, so you can see the blinking light or blinking indicator. In that type we use the enable blink option. Okay, and we can also select the rate, whether we want the slow, medium or fast blinking. After you fed all the details, you have to click on, after clicking on the OK, then we will get all the settings. Then we have to click on the test, and we can do the labeling of our input and output components, input switch and the output light. Now we also want to monitor both the switch and light status. For that we have to add a hash. Okay, we have to add a hash for both. So you have to add hash for a switch also as well as light, and by clicking on the hash we can adjust the properties of that object type. Got it? So when you click on the hash, this property window will appear, as you can see in the figure. It will allow you which type of display value you want. Okay, since if you want for the switch, it is only for the discrete, so we will select the discrete type. Okay, and after that different window will appear, in which we will provide this the same name in the expression, and will be message for on or off condition. For example, if the switch is on, whatever status you want or which message you want to appear on the screen, and if it is off condition, what message you want to appear on your development window or on the screen. So here we have used 1 for the on message and off for the 0 message. Okay, after same process we will do for we have done for the light also. So after completing all this, you have to click on the runtime. As you can see in the figure, the symbol of the runtime, you will get the output window. The case 1 is there, when the switch is off, 0, the light is off, and when the switch is on, the light is on, as you can clearly see by the light of your output indicator. Okay. Now next, when you will learn how you can add the input, how you can add the output. Similarly, you can add the other components also. The tagging is important, or you can also have the functions to detailing also. Okay. So next we will learn how to do the SCADA program for the logic gates. Okay. So for the AND gate, for the gates we know we need the 2 inputs. So similarly, we have added two input button switches like A and B. Okay, and 1 output indicator as the light. Okay, the same process which I have discussed, you have to do for both switch A and B and for your output indicator. But where the thing is, here while for the output in the expression, in the previous example we have directly entered the tag name SW, because we have to link directly the input switch to our output indicator. But here we have to consider both switches cases. Okay, so here for the AND gate we will use the expression A and B. So you can see in the light wizard, in the expression you have to see A and B. Okay, then after clicking on the runtime, you can see in the output. So when the A is 0 0, output will be 0. When the 0 1 case, output will be 0. For 1 0 case, output will be 0, and when both inputs are high, output will be high, and your light indicator will turn on green. Okay. Similarly, for the second logic gate or gate, the same process is there, only the expression will change. The expression for OR will be A or B. Got it? Simply the same process. For the input 0 0, output will be 0, 0 1 1. For 1 0, output will be 1, and for 1 1, output will be 1. So for only for the both 0, output will be 0, and for the rest of the 3 cases, our output will be high, as you can see in our light indicator. Okay. Next is our NOT gate. Here we need only 1 switch and 1 indicator. Simple, but the expression will be not A, because we want the vice versa. If our switch is 0, output will be high, and if our switch is 1, output will be 0. So, just you have to change the expression in the light wizard or your output wizard. Got it? Now, for what? For the special gates. Okay, but you have but in the SCADA on this software there are only 3 expressions for logic gates, basic operation like the A and B, A or B and not A. I want to keep note of this, that and for the NOT gate, no, you have to use not A expression. A not expression is not correct. Okay, when you want to use the not for the NOT gate expression, you have to use not before your symbol. Got it? Okay. So, for similarly for the NAND gate, we know that it is a not of the AND operation. So, similarly we will add not in front of A and B. Okay, then we can get the expression for the NAND gate. Similarly for the NOR gate, we know it is a not or the opposite of our OR operation. So, similarly not of A or B will gives the NOR gate expression. Similarly for the XOR gate, we know the expression for logic expression for our XOR gate is A dot B bar plus A bar dot B. So, how you can write in the expression form A and B, because the dot or product means signifies the AND operation, plus signifies the OR operation. Okay. So, A and not B or not A and B, this will be the expression for your AND gate. Similarly for the XNOR gate, we have the expression A dot B plus A bar dot B bar. So, how we can write it in this expression in our SCADA software? We have to write A and B or not A and not B. Okay. And we also know that the XNOR is the NOT operation or the reverse operation of the XOR gate. Okay. So, we can also use the NOT of the XOR gate expression. So, then also we will got the XOR NOR gate expression. So, so this is very simple. By this you can generate any gate expression, just you have to change the expression value in your light wizard or your output wizard. Okay. We have only 3 and not and or, and by using these combinations not and or, we can generate the expression for NAND, NOR, XOR and XNOR. Okay. Okay. So, next we will learn we will go to the next example, how we can move any object in horizontal or in the x direction. Okay. As you can see in the figure, we want that you can see there is a slider having a value 0 to 100 and there is a ball and their positions are written as A and B. So, what we want that when I move the slider, when we move up the slider, my ball will move. Okay, which means through the slider movement we are controlling, we want to control the motion of the ball. You can consider a ball in the form of any product in your plant, industry process. So, here setting just by the slider operation, but just by moving the slider, we can control the motion of any object. Okay. So, here we are controlling the ball, red ball by our slider motion. Okay. So, next when you similar how you can add the slider, click on the wizard option like I have shown you, click on the wizard option. Here you will get the slider, select the slider, then you will got all types of slider types of slider there, choose which one you want. Okay, I have chosen this type of slider value. Okay, then after clicking on the slider, the slider wizard window will open. Okay, in that window it will ask you to enter the tag name. So, I have added SL as the tag name for the slider. It will also allow you to which label you want. Okay, so for the slider, the label I have added the slider which will appear on your development window. Okay, then it also allows you to choose the color of the fill color and also the test color. Got it? It will also there is also property through which you can set the slide range. Means if you want the range in which you want your slider to move. Here I have chosen 0 to 100 range. Okay, with the major divisions of 5 and minor divisions of 3. Okay, labels also in labels part also you can also check the where you want to the label value. Got it? This is how you can select all the properties or the detailing of your slider window. Then after this you can click on OK. Then if you want to monitor the status of your slider, like I have explained earlier, you have to select you have to put a hash mark, and when you click on that hash, it will open a window where you can select all the properties. If you have remember, in that window I have chosen the value display as discrete, because this is the switch where we have only two values, 0 and 1. But here this is a slider, we have a range of values, we can vary it from 0 to 100. So here we have to choose display value as analog. As you can see in figure, I have chosen the analog value. When you will click on that, it will ask you for the expression. Okay. So we want, which in this hash we want it to link to our slider. So we want here we have to add the tag name of the slider, which status you want to save. Okay. So after selecting the tag, entering the tag name, click on OK, you can proceed. Simply now the step 3 is how we can move the ball. Okay. For that, first select the position of the ball, select the ball, then you will get the x and y coordinate of the ball or the current location of your ball. Here you can see in the bottom bar, x and y, x is 300 and y is 150. Okay. Next we want it to move to the B location. So we will move our ball to the B location, then we will check the locations there. X is 520 and y is 150. In this example, we are only changing the x direction. We are the y is constant. Okay. Now if you want to select the properties, so select the ball, click on ball again. This window will appear. Okay. Here we will set the location. In here you can see there are two options there, either vertical or horizontal. It's an object, so it want which direction we want to move. So we want to move our ball in the horizontal direction. So here we have to select horizontal. Got it? After selecting the horizontal window, it asks us to provide the expression. So here we have to add entered the SL as the expression. SL, you remember, the SL is the tag name of the slider, because we want to link the motion of the ball with the slider motion. Here we have to add that expression of slider. Okay. So here we have added SL as the expression. Then it will ask us the property at the left hand 0, at the right hand 0, 100. Okay. For example, when it is at left hand, how value we want from the 0 to 100, and for that value which horizontal movement we want. Okay. So when it is at left hand, when the slider is at 0, it will be at 0, and the right hand is at 100, the ball should be at the 220. How this 220 appears? Okay. So we have checked that initially in the A position the x value is 300, when it moves to the B position the x position is 520. Okay. So the difference in the x position is 220, means from A to B it has covered 220 steps. So here in this we have to the left 0, we have changed to right to the 220. Okay. Similarly for the value 0 to 100. After you have done this, if we want to change the mode from development to the runtime, you have to click on the runtime. Okay. Now here you can see, when you can see in the figure, while we are moving the slider, the ball is moving from A to B. Here the slider value is 35, ball is in between A and B. Okay. Clearly, if you want 0, the ball will be at A position. When you move, ball will become at 50, the ball will be at center. When it will become 100, ball will reach to the end point at the B part. Okay. This is all about how you can move the ball in the horizontal position. Now we will see how we can move any object in the vertical or the y direction. As you can see in the figure, slider is same, ball is same. Now the B location is at the horizontal or the vertical place above the A. So we have to move the ball from A to B location. Okay, so when we click on the slider, the same slider window will appear. Okay, here you can select the same properties if you want nothing, and if you now we want ball to move from 0 to from A to B part. Okay, so same procedure will be there for the slider. Now here when you click on the ball, here we have to change the location from horizontal to vertical. As you have seen earlier, I have chosen the horizontal. Now here you have to select the vertical location. Now the value is at the bottom, slider value is 0, at the top it is 100. Similarly for the 0, down value y will be 0, and it will move up, slider will move up to 100. My ball should move up to 160, which is, for example, it will take the 160 changes in the y coordinate. Okay, it's clear? When it's 0, slider, the ball will be at 0. When it will reach at the top, slider will reach at the top at the 100 range. The ball location will set y to the 160. Okay, similarly, as you can see here in the figure, at 35 ball will be in between. Okay, and when you move it to when you keep moving your slider up and down, up, the ball will move up towards the B direction. Okay, so it's a very easy. Now we will learn how we can move any object in horizontal as well as vertical direction. Okay, as you can see in figure, we have mentioned 3 points A, B and C. So first we will move our ball from A position to B position, then we will move our ball from B position to C position. Slider is same with the range 0 to 100, and while sliding from 0 to 100, I want my ball to move from A to B and B to C. Okay, means at the 0 ball should be at A, and when it is 100 it should reach to the target position C. So how we can do that? Simple, we have to select a slider first, same steps. You can set the slider properties by clicking on that, and if you want to set the status of the slider, you have to add hash, and by clicking on the hash you can adjust the properties of your slider. Got it? Next, we want our ball to move horizontal also and the vertical also. So while clicking on the ball, the wizard option will appear, or the detailed block will appear. Okay, here it will give you option to select the location. So when you want to move horizontal, we selected horizontal. When you want to move vertical, we have selected vertical. But in this program, we want our ball to move vertical as well as horizontal. So we have to select both. Got it? Because in this example, we want to move our product or move our ball in the both directions. So we have to select both options. Okay. So when for the horizontal option, the expression will be same SL. For the vertical position option will be, the expression will be the same SL, because we want to link to our slider motion. Okay. As you can see in the horizontal location, and the left hand for 0, we want 0, and for the right hand 50, we want our ball to reach from A to B position. So we will change it to the 220. Okay. Same. Similarly, for the vertical position or the vertical location, you can see for 50 to 100, because you can see the slider range is 0 to 100. For 0 to 50 range, we want our ball to move from A to B, and from 50 to 100 range, we want our ball to move from B to C. Okay. So while we are sliding our slider from 0 to 50, our ball will first move horizontal from A to B, and when we will move slider above from 50 to 100, our ball will move vertical from B to C. So you can see here at the left hand it is 0 to 50 for the horizontal location, and for the vertical location it is 50 to 100. And here in the vertical motion it is moving upward. So the further down it is 0, and for how many steps you want to move your ball upward, you have to put there. Got it? So in the next session we will explore more on this SCADA programming. Okay. Till now, bye bye. Thank you. Happy learning.